All right, let's look at the homework 10.2, problem number 7. All right, so we want to find the area of this given ellipse. So the parametric equation is x equals a cosine of theta, y equals b sine of theta. So the ellipse looks like this, right? X-intercept is a negative a and positive a, and the y-intercepts are negative b and a positive b, right? So since I'm lazy, so I'm going to just do 1/4 of it and then multiply by 4. So I'm going to just pick, I'm going to find the area of just this part, right? And then multiply by 4, right? So area A is going to be, so I'm going to set it up in terms of x and y first, right? So you have to multiply by 4 because I'm going to find 1/4 of it. So it's an integral. All right, it's x is going from 0 to a. So we have 0 to a. All right, then y value is y, so it's going to be y. Then do it with respect to x. All right, so that would be the area, but in terms of x and y. We're going to rewrite it in terms of theta. All right, so this is going to be equal to 4 is still 4, then integral, right? I'm going to do the limits later. Y is given here. Y is a b sine of theta, right? All right, then we have to come up with dx. So dx can be found by doing this. All right, here's x. I'm going to take the derivative of x with respect to theta. So we're going to get a is just a constant. Right, derivative is negative sine, so it's going to be negative sine of theta. Right, so that's that. Then if you just want the dx, so we can simply multiply through by d theta to get this. So dx is equivalent to negative a sine of theta d theta. Right, so we're going to put negative a sine of theta d theta. Right, so I'm going to simplify a bit. Actually I have to put the limit. Right, so when x is 0, so here, right, then angle would be theta is going to be, so theta starts from here. And then this angle is pi over 2. So we're going to start from pi over 2, right? Then it's going to go to here, a, but that's going to be angle is going to be 0, right? Because cosine of 0 is 1, which gives you a. So here, right? All right, then let's see. I'm going to pull out the constant. So b is a constant and the negative a is constant. So I'm going to pull it out. Actually, I'm going to do this. I'm going to use this negative sign, turn it into positive, and I'm going to switch the upper limit and the lower limit. So instead of going from pi over 2 to 0, I'm going to go from 0 to pi over 2. All right. Then I'm going to just pull out a and b outside. So a and b outside there, right? So we're going to get here, this is going to be equal to, right, 4ab, right? Then we just have, so we have what's left. So we have an integral from 0 to pi over 2. And you have a sine times sine, so you're going to have a sine squared of theta d theta, right? But this is going to be equal to, so you know that using a trig identity, sine squared of theta is 1/2 1 minus cosine of 2 theta, right? So I'm going to combine 1/2 and 4. So I'm going to get 2, right? Then we still have a times b. So I'm going to put ab, right? Then we need to take the antiderivative. Antiderivative 1 with respect to theta would be just theta. Antiderivative negative cosine of 2 theta is negative sine of 2 theta over 2. And then this is going from 0 to pi over 2. Right? So this is going to be 2ab is sitting there. Right? And we plug in pi over 2. So you have pi over 2. Minus, if you plug in pi over 2 here, sine of pi is 0. So it's a minus 0. So I'm not going to write that down. And minus, if you plug in 0, theta is 0, sine of 0 is 0. It's, everything else is actually 0. So we get that. So we can cancel 2 on top and a 2 on the bottom. And we end up getting pi times AB. All right. So let's type it in. All right. So we got the pi AB. So I'm going to write down pi, then times AB. All right. All right. Let's check the answer. All right. I came back and looks like we got this one correctly. All right. That's it. I hope that this was clear.